Welcome to Study Loop.
Okay, so for part A, we have theta 2 is equal to negative 90 degree. If you use the right-hand rule, you can tell that the wire at 90 degree have 0 y components. This means that the wire 2 is either at 90 degree or negative 90 degree. Since the wire 2 should pose in motion that is against the motion of the wire 1, so therefore the angle for the theta 2, which is the angle for wire 2, should be equal to negative 90 degree. So now let's take a look at the part B. We know the magnetic field can be equal to mu 0 I over 2 pi r. If we do some arrangement here, we have I is equal to 2 pi rb over mu 0. So we know the magnetic field in this case is equal to BYS, which is equal to 4 microtesla. And 4 microtesla is 4 times 10 to the power of negative 6 Tesla. And we know the permeability constant is 4 pi times 10 to the power of negative 7 Tesla times meter per ampere. And R in this case, which is the radius, is given as 20 centimeter, and 20 centimeter is equal to 0.2 meter. So now let's plug in back to the equation to determine the currents, which is equal to 2 pi times 0.2 meter, and then times 4 times 10 to the power of negative 6 Tesla over mu 0, which is 4 pi times 10 to the power of negative 7 Tesla times meter per ampere. And this will give us the currents for the wire 1 is equal to 4 ampere. So now if you use the right hand rule, you can tell that for such current, the direction should be on the page. So now let's take a look at the currents in wire 2, which can be also set up with such equation here, which is I equal to 2 pi rb over mu 0. So now the magnetic field is equal to 2 microtesla, which is 2 times 10 to the power of negative 6 Tesla. And the radius is the same, which is 0.2 meter. So now let's plug in back to the equation to determine the currents, which is equal to 2 pi times 0.2 meter, and then multiply by 2 times 10 to the power of negative 6 Tesla over 4 pi times 10 to the power of negative 7 Tesla times meter per ampere. And this will give us the currents is equal to 2 ampere. So if we use the right-hand rule, the direction for such currents should be into the page. And these are the answers for this question.